Historically, it's been mentioned today several times, I think, aviation systems are really planned for a 20 to 30 year, even longer cycle when we talk about both commercial aviation and military platforms, as well as general aviation. But with the rapid evolution of changes in both technology and developmental tools, we're really looking at shorter life cycles, even for those avionics and systems that provide some safety critical functionality. And some of the new aircraft use cases, such as UAS and AAM, are going to be taking advantage of these capabilities with the goal of bringing some of those life cycles down to less than 5 years. So to discuss some of these technologies that are making all of this possible, we have a great set of panelists for you, moderated by Mr. Brandon Suarez from Reliable Robotics. Brandon leads the development of technical standards and global aviation policy for Reliable. He's focused on airspace integration and international operational approvals, and he supports product strategy plans and future aircraft programs. Brandon's deeply involved in the aviation community. He's an advisor to ICAO. He's co-chair of Special Committee 228 at RTCA, and he chairs the Aerospace Industry Association's Emerging Technology Committee. He's also active in several NASA research activities, seeking to advance future aviation concepts, and is an instrument-rated commercial pilot as well. So, Brandon, over to you. Got a great panel. I'm anxious to hear what they have to say.
Awesome. Thank you, Terry, for the introduction, and thank you to RTCA and EuroK for hosting this important 2-day event. I was able to dial in earlier, and I've personally learned a lot, and I found it just really insightful and helpful as we figure out how to move forward. I mean, we're all aware of some of the contemporary issues. You know, a lot of discussion today about the 5G impact on C-band radar altimeters, and it's only going to get worse, as we've heard, in terms of both the spectrum congestion issues and the economic competition that's coming for aviation. So the panel today, I'm really excited, having gotten to sort of handpick the folks today. I'm excited for this. We're here to talk about how to use adaptation, how to shorten aviation product development life cycles. I think we've all benefited from the use of consumer electronics, both in general aviation. In my case, you know, I love flying with an iPad on my flight deck. And in the case of new entrants, right, like we said, that are trying to bring the life cycles down to the matter of years and months rather than decades. So we're very fortunate today to have really a great panel. I'll just provide a quick sort of 1-sentence intro and then direct the audience to the platform to get a longer bio and learn more about what these folks are up to. So first of all, we have Dr. Jim Davis representing uAvionix. uAvionix is a company that's dramatically shortening the life cycle of certified avionics products using modern processes and technologies. We've got Mr. Jesse Turner, who represents Boeing and is the co-chair of RTCA Special Committee 186, and so he's well aware of the length of aviation and avionics development timelines, having led the ADS-B effort for a long time, as well as, you know, at Boeing, where they're planning for aircraft to be in service for 40+ years. We've also had Bruce DeClean representing the FAA. Bruce has had a number of roles and responsibilities at the FAA over the decades, and is now involved in regulating new technology and bringing together really the complexity both of the airworthiness certification process and the operational approval process through flight standards. We also have David Solar from EASA, who's responsible for general aviation and advanced air mobility. And so he's really on the forefront of rolling out new technologies and new capabilities in Europe. So again, I want to encourage the audience to enter your questions into the system. And we're really hoping, all of us on this panel today are really hoping to have a dialogue and a conversation. So please put your questions in. So while you're doing that, in order to sort of bring each of the panelists into the discussion, I'll just start off with a question and give them a chance to unspool a little bit. And so I'll start with Bruce. So Bruce, to get us started, could you just give us some thoughts on the FAA's efforts to accelerate new technology development and deployment in the NAS?
Yeah, absolutely. Thanks, Brandon, and a pleasure to join you this morning and have hopefully a good discussion. As you noted, I have a long career in the FAA, largely working avionics and regulation, and I want to kind of emphasize, we have the part of the responsibility for safety and interoperability as it's relevant, not the spectrum allocation, which is kind of its own regulatory topic. So, but just kind of thinking about safety and interoperability, we have made a concerted effort as we develop rules and requirements to migrate to performance-based requirements. And what's important about performance-based rules is they have kind of a built-in agility, so that as long as the desired performance can be achieved, the means of compliance can evolve. And that is true in the radio and technical space as well, and hopefully provides basically change-ready rules as technology comes along. We also depend very much on the use of voluntary consensus standards. So, we don't expect in aviation that we really have the resident expertise for every new technology and innovation. We work together with industry in that area and ask industry, how can you step forward and develop industry consensus standards? So when you think about the life cycle and how long it takes to adopt new technologies, a key component of that is how long does it take industry to develop a standard to use for that new technology? In the meantime, before those standards are developed, one thing that you see us doing a lot in our current projects is taking full use of our agility in project-specific criteria and methods. So we had recently published for comment the proposed criteria for Joby aircraft as an example, AAM, the first of the AAM aircraft that made application in the United States. And that criteria is specific to that project. And we'll be publishing more criteria for additional projects. So we have a lot of flexibility in the US system to tailor what we're doing to specific projects in the immediate term while those performance-based rules and voluntary consensus standards are developed. And that's really how we handle safety. I wanted to just take a minute to kind of tee up for discussion interoperability and the role of interoperability. In a lot of the spectrum utilization in aviation, there is an industry standard that is invoked by us, let's say through a technical standard order, that specifies very detailed technical criteria of signal design, and that is necessary in some cases for interoperability. TCAS is a great example I would highlight. We depend on TCAS as a safety enhancement to reduce the risk of collision between aircraft. That only works when the radios in those aircraft are able to talk to each other effectively, and they are constrained by that standard. So in that case, again, the pacing item from the regulatory standpoint tends to be the development of the new standards. Once the standard is developed, then it largely is a market question, and I'm sure we'll have a lot of good discussion about that. So those are some initial discussions, and I'll turn it over back to you, Brandon, for another question.
Great. Yeah, no, that definitely gets us rolling. I'm getting a few more questions from that. So thanks, Bruce. David, next to you, I'm really curious as a general aviation pilot myself. I'm curious how you think technology that's being used in general aviation can, especially when it comes to RF spectrum, can be leveraged for new entrants like urban air mobility and regional air mobility and small UAS.
Yeah, that's a very interesting question. Thank you, and good morning or good afternoon, everybody. I would split, the question in two, and I guess for non-commercial operations, non-air taxi, I would say that would be there. I think we could leverage all the GA technology that is around, which is fully applicable, fully aligned. They will use the same airspace, the same kind of usage. So I do think this part of the business will be fully adopted the GA technologies that are developed today. Now, on the other side of the coin, I think we have the extreme usage for commercial operations, and we all know that if we look at urban air mobility or advanced air mobility, whatever we call it, in the future, it's a large operation at scale, more like airliners, if we like, even though the shorter flights, but much more numerous than GA. I'm not sure some GA solution as of today would fit for several reasons. The first one would be, these operations will be extremely data hungry. They will need data on the machine-to-machine interfaces, machine-to-machine exchange of informations. On the communication side, with whatever it will be, we have a use space definition in Europe, for instance, and weather also probably, some of them will not be able to fly in icing conditions, so we'll have to forecast quite accurately the weather, and weather stations will be all around the places. Site availabilities, whether they are contingency site on locations if you have an issue, health monitoring, vertiport data, passenger data, and also something which is probably new, which is I call it multimodal data of transportations. I do think all these vehicles and the business case will be useful if we are able to connect to other means of transportations, and in a seamless way via platforms that are today in development. And it means integrating with trains, with airports data, with local city train, maybe taxis also, ground taxi, and all of that is really a challenge by the volume, but also by the fact that it's non-aviation kind of communications and spectrum. So we'll have obviously to make our ways and to adopt also non-aviation protected spectrum bands and to work with that. The second aspect also for this specific operation is the availability of services. We will have to have a guaranteed availability of services in some instances for some of the applications which are safety related. And so far, yes, there is aviation spectrum. There are also some other capabilities, and like 5G, you can have some reliability of services that are embedded into that, and we need to share with the whole community and obviously the whole bandwidth. And on the third point is these vehicles will operate into airspace that are today under definitions, and at least in Europe it will be a use space, and we have the first regulation that came out. And within that, we have a e-conspicuity mandate. So every use space user will have to be e-conspicuous, and it includes not only urban air mobility, but also UAS and any users that will enter into this airspace. And that's a game changer also. At least, I know that in the US, there is an ADS-B mandate for almost everybody, but not in Europe. So it will change a bit the game. Obviously, to do that and to introduce all these novelties, we'll need to be aligned, both on the aviation side and non-aviation side. That's one of the points we need to open up a bit more. And you mentioned it, speed up the adoptions of some technologies. And for that, I hope we'll take the problems not upside down. Sometimes we did in the past, if I take data link, for instance, almost each case was then leading to a standard, and we are ending up now, I think, with 15 standards around the place, rather than having a more okay, what are the end user needs, and develop a standard that is fitting everybody. And that's really the goal. And to develop these standards, we have some regulations that will probably go hand in hand, and in parallel we need, as Bruce mentioned, the industry standards. And instead of waiting for the regulations, we need to work in parallel. That's what we are trying to do, for instance, in the ACAS XA development in Europe. We have currently NPA, a Notice of Proposed Amendment, on the regulation, which is ongoing. And in parallel, we are working on the standards. It's a bit more risky approach because you have to, at some point they should be aligned. But I think it's the only way to reduce the life cycle and shortening how we introduce these kind of things. And lastly, on the 5G story all over the place showed that industry and aviation industry can react fast. So that's a good sign. Now, when you look at the amount of resources we had to involve into this issue and solve it, may not be commensurate to the exact risk. So that's something we need to find and fine tune, obviously. But really, at least on the other side, we are committed to work hand in hand with industry and other stakeholders beyond the aviation ones to make sure it's going to happen and introduce in a safe manner.
Great. Yeah, thanks for those thoughts, David. Jesse, turning next to you, you have a ton of experience. You've been in the ADS-B world probably since the beginning. And I'm just curious if you might walk us through some of the things that the community, that especially new entrants, but as we move forward with all of aviation, trying to adapt faster, what are some things that our community can learn from some recent examples of these global technology rollouts like ADS-B?
Yeah, ADS-B, of course, was a pretty significant effort worldwide. It wasn't just a regional thing, and so it obviously took a number of years to go from start to finish. And like any significant new technology introduction, there are lots of variables, lots of risks that we have to account for in each phase, all the way from requirements development, industry standards development, as well as the detailed design, testing, all the certification activities, and then of course finally with the implementation. And each one of those has its own risks, lots of variables going on. And so one of the lessons learned is when you think that you're going to do it in a certain amount of time, believe me, it's going to take a lot longer. And I think everyone smiling on the video has gone through this, right? You have a plan, and of course, over the course of time, that plan adjusts to the realities as we go along. And so we have to be flexible as an industry to account for those unforeseen things that come up. But as far as some of the lessons learned, as Bruce alluded to, industry standards and interoperability is key. They're vital to our industry. I'm speaking from an air transport perspective, of course. Everything that we do relies significantly on those industry standards. So getting everyone to the table, I think in the case of ADS-B, it was quite a success because we had, of course, all the industry participants, whether they be avionics, developers, manufacturers, the airframers, but probably more importantly, we had a number of regulators worldwide that were involved in that industry development. And when you have that, and also want to mention in the case of ADS-B, air navigation service providers, basically their air traffic control arm. So when you have everyone worldwide involved in that, you can actually come to consensus on requirements that early. That is very much key to actually having a successful implementation. In the case of Boeing and airframers, of course, and operators as well, everything's operated worldwide. So it's very important to have that interoperability. And so developing those key standards in the performance requirements early with everyone involved at the table, I think was key. And even once we got to the point where we actually had the standards produced, and we had the regulatory material, the advisory circulars and TSOs supporting those, there was still a lot of coordination that had to occur. And I want to give credit to a lot of regulators and industry groups that supported ADS-B, because those were key forms that people, even though the standards were produced, to get people together and even educate folks. Example is Equip 2020 in the case of the FAA. I think a huge success because they brought folks together because yes, the standards are out there, but there are always implementation questions, and there are always topics and key issues that are developed as you're going through the development and the certification. So, in the case of the United States, FAA with Equip 2020 was a success. In Europe, Eurocontrol held surveillance forums as well, and for the implementation over there. ICAO Asia Pacific regional office held annual meetings with all the key stakeholders, including regulators and air navigation service providers in Asia, again, to come up with planning as well, execution, and also what are some of the issues that are coming up. So having that forum and worldwide forums were very key. And probably lastly, having as far as air transport is concerned, and the speed at which we develop and field things, there's one thing about being able to develop the actual standards and actually design the equipment and come up with it. It's quite another to actually get it implemented. In the case of ADS-B, we're talking thousands of airplanes worldwide. And aircraft fly in the air transport world. It's a different group than consumer electronics, of course. I mean, aircraft operate 20 hours a day. There are very few times where you have enough time to actually, the airplane is down and you're able to take advantage of that. A checks, which are only a day long, doesn't provide sufficient time. So B checks, which account 18 months to 2 years, is really the only time when an aircraft is down. Otherwise, to pull an aircraft out of service to implement some of these technologies, that's a huge impact on operators. And kind of the story with getting any new technology on an air transport airplane, it's either you have to, it either has to be mandated or it really has to buy its way on the aircraft. And so in the case of aircraft or changes that aren't mandated, the return on investment has to be very short, and the operational capabilities and the benefits that the airlines realize out of that technology need to be very relevant. And so it's a different paradigm, of course, than the consumer electronics. And so we taking that account, we in terms of implementation, we have implemented things like software data load. The later aircraft have that capability, networks, so that you don't have wiring changes. So we have done things in the air transport world to be more expeditious in implementing new technologies, and so we'll just continue to do those.
Awesome, good, Jesse. Yeah, thanks. That's a lot of good wisdom, a lot of nuggets there to unpack. Jim, lastly, I wanted you to go last just because I thought you might have some things to respond to from the previous panelists. But what I really want to ask you is, what are some things that your company is doing differently from maybe some of the legacy aviation developers to deploy certified products quicker?
Yes. Well, first of all, I'll begin by saying that many of Jesse's comments regarding air transport certainly migrate down into general aviation. We have the same hurdles coming up with standards and getting them turned into TSO products that make the airspace safe. And in fact, uAvionix vows that it was founded basically to keep the level of airspace safety high, despite the introduction of things like unmanned air systems, those sorts of things. Anyway, what we may or may not do differently than some or all of the legacy people, we look at the life cycle of products and we attack the front end. We recognize that things are changing faster than they have in the past, and certified products are needed perhaps more quickly than in the past. And one way to make that more palatable to users is to decrease the cost. If you bought a product and installed it, and the overall cost isn't that great, you're much more likely, when the technology changes or the rules change demanding new products, you're much more willing to swap it out for something new and better. So to that end, we sort of approached it, we've used a two-prong approach. One is to make equipment smaller. In fact, we're probably best known for making very, very small miniature products. We make, for example, both certified and uncertified transponders with ADS-B out. We have a certified Mode S transponder with ADS-B out. It's class 1, which means it's high power. It's level 2. It weighs 50 grams. It weighs hardly anything. You can hold it in the palm of your hand, not even really notice it. We make a GPS that's very small, combined antenna and receiver that weighs 20 grams. It's about the size of a silver dollar, but a little bit thicker. And these are primarily aimed at the small UAV market, which we see as a growing market. The key to getting those certified, well, first of all, the key to keeping it cheap, and which you want to finish the product before you certify it, is you want to take advantage of new processes. Many of those processes depend on very sophisticated modeling and simulation software. And by using that knowledgeably, you can reduce the iterations required to get to a final product. And if you reduce the number of iterations, you've reduced the upfront costs that have to be recovered, and the product can be less expensive. And if it's well designed, then potentially you can ease the installation costs, which can be a large contributor to the overall life cycle cost of the product. So we do all that, and oftentimes we do it in close cooperation with the FAA, who in the civil world has to ultimately certify it. For example, our GPS, we actually started with a commercial GPS core. We didn't develop it from scratch, but the all-important integrity software that generally goes with an aviation GPS, that we did. We basically started with some very reliable hardware and surrounded it with very reliable, in this case, it was design assurance level C software. And the result was something that ultimately earned a TSO C145 Echo class Beta 1 certification. So that's a little bit different than what I understand many of the legacy suppliers of GPS have done. And this unit, TSO product, sells for less than $1,000, which astounded me, because I actually started out in avionics in the GPS world, actually back when Bruce, who spoke earlier, was sort of the FAA guy on the RTCA committee working that problem. And it's, well, I'll get into another aspect. As I mentioned before, one of the costs of a new product and adapting a new product to a new environment in the airspace is the installation cost. It's not unusual to buy a piece of equipment, but the cost of installing it into the panel can exceed the actual cost of the equipment itself. And that drives pilots crazy. We actually found a way, and this was partly working with our FAA people, to make sure everything was kosher. I would call it creative installation, where instead of installation taking hours, days, whatever, you could actually do it in under an hour. We actually have products, many of the people listening to this probably may even own them, where we recognized that airspace requirements were changing. ADS-B was being developed and was being mandated, in fact, and there was hesitancy on the part of many pilots to adopt it. They didn't want to spend the money. What we did was we came up with low-cost products through modeling and simulation and having good people working the problem. But we also came up with an installation scheme that didn't cost a lot of money. And in fact, I have some, if we can show a slide as an example, yeah, that'll be fine. This is a sky beacon that we did. The key thing here is because we were also catering to the unmanned air vehicle market, especially the small unmanned air vehicle market, we had a very small, very lightweight components that you would need for an ADS-B system. So what we did was, most airplanes, many general aviation airplanes have a light on the end of the wingtip. So, and that wingtip has 2 power leads running to it. So we would remove the light and we would replace it with this picture you can see, what we call sky beacon in this case. And that contains a 978 megahertz UAT transmitter for ADS-B out. But ADS-B also needs a GPS. Well, we have a 20-gram GPS that's TSO, so we stuck that in there. We put in an antenna that had sufficient coverage to give you the antenna pattern that you need. But wait a second, we removed the wingtip light. Well, we also put in a wingtip light that we had to TSO, and the result is what you see. Now, you may be thinking, if you're familiar with ADS-B, well, what about squawk code? You can't really pre-program the squawk code because it might change during flight. Well, it turns out that electronics, avionics aren't perfect, neither is the power system on an airplane. And when you transmit a squawk code from the transponder, which is already there, remember, we're only introducing ADS-B, we're not replacing the transponder already on the aircraft. When that transponder transmits the squawk code, it's a high power that causes dips in the power supply. And we actually have a code reader built into the Sky Beacon product that looks at the power going to the wingtip light and looks at the dips and knows what the squawk code is effectively. And then it puts that into the ADS-B, and you now have an ADS-B out system, and you really haven't had to touch the panel. All you've had to do is remove a wingtip light, hook up the power leads to Sky Beacon, screw it all down, and off you go. So I think that's
thanks.
That's a little bit different.
Yeah, and a good example of adaptation. You know, I think there were probably 3 or 4 examples there of adapting to a use case that is very different from what had come before it.
Yes, so
it makes a lot of sense. We've had a few questions come in from the audience, so I just want to make sure we get a few minutes to address some of those. Kind of have to toss all my questions to the side here, but there was a good question about, you know, Bruce, earlier you mentioned performance-based regulations, and Jesse, you talked about having to equip, you know, thousands of aircraft worldwide with ADS-B. And I'm curious, someone in the audience is curious how we overcome this regulatory approach in aviation where we tend to cater towards the lowest performing aircraft or the sort of minimum use case, almost to the detriment of everyone else, or at least the advancement of a particular technology.
I'll jump in first. I think, we work hard with industry to make sure that the minimum standards don't limit the maximum capabilities. So sort of individual solutions can overperform, and there's no requirement against that. I think the way I take the spirit of the question is, it is interesting. There always is a minimum. There always is some market solution that just barely meets the requirements. I think if the conversation is the minimum in the right place, that goes right back to the industry consensus body that's developing the standard, which we sort of challenge them to have that as a robust debate, and hopefully arrive at a consensus outcome. On the rulemaking side, if it does involve something that we have to impose, we go through a fairly disciplined rulemaking process, which includes consideration of alternatives and costs, et cetera. But so I think the spirit of the question really isn't about enabling the maximum, which you can already do. It's really, where is the minimum, and is it drawn in the right place?
Yeah, and add on what Bruce said. I mean, I totally agree. I mean, anyone that's been involved with standards development committees, you can argue for half a day over just one requirement on performance requirements, and it's consensus based, and you listen to everyone's inputs, and at the end of the day, though, it's made clear that the outlier does not dictate what the end requirement will be, based on our experience. You don't over design to it, but as Bruce said, there is a minimum performance level that's specified, and but outliers that are underneath what's considered state of the art at the time, those really are thrown out, because as long as the consensus is that you can meet a particular performance level, that's what you're going to go with.
I would only add that the committees go through an extremely large amount of creation of documents about how the equipment is used. They come up with standards. People agree with the standards, or there are non-concurs, then there are reviews, and the non-concurs, a great deal of effort goes into finding the happy medium. A lot of work goes into that. And people still make better equipment. They may charge more for it, or they may do something different. That's the way the market works. Some people will buy it. Some acceptance pilots demand that. Others won't. And as long as the minimum is set right, as Bruce pointed out, you maintain the airspace safety.
Another question from the audience. So obviously our panel today had the term adaptation in it. So just curious on your thoughts, given everything that's been said, what are some practical ways that we can build flexibility into avionics and RF systems and regulations going forward?
Software defined. Oh, sorry, go ahead.
No, go ahead, Jim. I think you were going to say pretty much what I was going to say.
I mean, software defined radios is sort of the poster child for all this, where, for example, there's now ongoing development of a C-band command and control radio for UAVs that have been set aside by the World Radio Congress and every ITU for use for command and control of UAVs. And it's over a range of, I think it's 5030 to 5091 megahertz. And you'd like a single radio that could sort of pick out a center frequency, whatever's assigned to it, and do it. And those software-defined radios work these days. You don't have to have individual, an analog switch to switch between inductors and capacitors to get the right frequency. And that's adaptability. Couldn't have done that a few decades ago, but today it's sort of the most logical thing to do.
Yeah, and along with that, on the implementation side of that, when you look at earlier generations of commercial aircraft, such as the 767, 4737, many of their radios were hardware based, non on wing software loadable. And as we've moved in time over to the latest aircraft, such as the 787, A350, et cetera, many more of those pieces of equipment are now on wing software loadable, which is huge when you take into account in terms of implementation. Being able to actually load something on wing. I mean, as an example, the ADS-B, when you compared how much time it takes to do an ADS-B retrofit on, say, a 767 compared to a 787. 767, you got to do interface wiring. You have program pin wiring right behind there, and then you have the hardware box swap. So you have to get a brand new piece of hardware installed. Versus the 787 network-based airplane, on wing, ADS-B implementation was on wing software loadable. Not only you didn't have any interface wiring to do because it's already hooked up to the network, no program pin wiring because you have option selectable codes that are onboard loadable. So as we've transgressed through the years to new airplane implementations, things have gotten a lot better on the implementation side as well.
If I can use a different example for a minute, the FAA promulgated new requirements for drones to have remote identification, the remote ID rule. And that's sort of a good intersection for today's conversation. We have both retrofit challenges because we require remote ID on all drones previously sold if operated in various parts of the country, and also a requirement on new drones. And what we did there is we embraced that performance-based strategy that I talked about earlier. So the performance requirements that we require are very general. They leverage commercial technology. So that's kind of another key element, is where you don't need unique aviation requirements, don't develop unique aviation requirements. So that rule actually requires the use of an FCC Part 15 radio, Bluetooth wireless, allows for an industry consensus standard that was worked in parallel to the rule, to get back to one of David's remarks and sort of the importance of shortening timeframes, and planned ahead for the kind of retrofit that Jim, you described, in terms of very small things that if you do have to retrofit and you don't have it in your small drone from before, how could I get a sticker? How could I get this thing down to the size of a sticker? And so I think that's a great example of kind of where we need to continue to chase those same strategies and migrate them up into larger aircraft.
Awesome. We're about out of time, so I just want to ask one more question real quick, and David, hopefully you can chime in. You mentioned, moving into spectrum that has historically not been open to aviation use, licensed spectrum, but not aviation protected spectrum. There's a question from the audience around this idea of the ability to potentially impose regulations or limitations or restrictions on other users in a band. They were using the 5G signals, maybe time of day or environmental sort of limitations that could be put on them. But what are your thoughts on the ability for aviation to maybe impose good neighbor requirements on other users in a licensed band? I think you're on mute, David.
Sorry. Yes, I do not think imposing is the right way forward. We have to find a consensus, and that's something, yes, you mentioned reducing the power. Actually, that's what we did in Europe. There is a limitation of the antenna power. It's not in the contracts of the provider, so they cannot emit at any level they wish, or the max power, which is sometimes very high. It's all over putting the right people on the right table and understanding each other, what are the constraints, and I'm sure, you know, we can find solutions. If we are imposing anyway, you know, if you compare the size of aviation industry compared to telecom industry, I'm not sure we will win the battle, to be transparent. So better we reach a good consensus, understanding in some spots, for instance, yes, it could be possible, and I'm sure it's going to be done. But really, that's something we have to not also live in our bubbles. We need to get outside and to recognize that things are moving on, not only in aviation but elsewhere. It's done also to be more aware of you know, the technologies that are being developed for other applications that we could embrace also. There is a question on off the shelves. Yes, it's often, you know, the big temptations but when you get down to, okay, will it fit for purpose at minus 40 degrees and also at some altitudes, then you hit the spot and you have a problems. But we can do better for sure on that by anticipating more, definitely.
Good. Well, thank you. I want to thank all the panelists today for taking the time for preparing this and for being on today. And again, thank you, Terry, to RTCA and EUROK for hosting the conversation.